So we're moving on to 8.3. And in this section, 8.2 was distributing a monomial times a polynomial, a binomial or trinomial. Let's practice that. This is a skill from 8.2 where we take this 3x and multiply it by 2x. And let's think about that. When you distribute 3x into 2x, you multiply the coefficient 3 times the coefficient 2, giving you the coefficient 6. And then we take the variable x times the variable x, and that gives us the variable x squared. Easy. And then we distribute the 3x to the other term, 3x times a negative 5. Well, a positive 3 times a negative 5, that will give us a negative 15. And of course, this x, when you distribute it, there's no other x, so it'll just come right down. And that's your final answer right there, 6x squared minus 15x. Let's try one more from last section. It's a little review. We're going to distribute negative 7. There is no variable on it. It's just an integer negative 7. Negative 7 times 2x. You multiply the number with the number, and then you bring down the letter x. So you get negative 14, bring down the letter x. Then negative 7 times negative 5, that is a positive 35. And we're done. That's it. I don't think that's complicated. Unless you don't know how to multiply, that might be complicated. But then again, we have calculators that help you multiply. So I think that's pretty straightforward, pretty easy. And that's what's going to make this next section, 8.3, straightforward and easy. So multiplying these binomials below, a binomial here, a binomial there, is pretty much the same as doing the two problems above. Check it out. Now normally, we're just used to, let me put a box right here. We're just used to seeing that. Oh, I'm going to distribute negative 7 times 2x and negative 7 times negative 5. We just did that above. And that's exactly what we're going to do. We're simply going to cover one up. Since there's two terms, we're going to simply cover one up and distribute one at a time. Yeah, I would start with the 3x, even though technically it doesn't matter if you start with the 7 or the 3x, but for the sake of getting your answer already in standard form, let's start with the first term, the 3x times 2x. And what do we get? 6x squared. And then how about 3x times negative 5? What do we get? Negative 15 with an x. Okay. And now, since I've already distributed the 3x, I'm going to ignore it now. And I'm going to distribute that minus 7. So distributing the minus 7. Minus 7 times 2x, what do I get? Negative 14x. And then minus 7 times negative 5, positive 35. After you distribute, always check and see if you could combine any terms, and you will see that you'll be able to combine these two terms. They're both x's. I like to circle or box in or squiggly underline on and combine the negative 15x with the negative 14x. That's simply you owe $15, you owe $14. You're going to owe a lot of money. You're going to owe $29. But in this case, 29x's. And of course, that 6x squared comes down. The plus 35 comes down. And that's it. That's your answer. So, if we compare, so this box, I just put it there so you could visually see that we ignore one and distribute the other one. We take turns distributing. So as we could see, this problem right here, it was really these two problems, but done at the same time, right? We distributed the 3x into the 2x minus 5. That's what we did. We took the 3x and distributed it into the 2x minus 5, and we got that answer, the 6x squared minus 15x. That's what we got for number 1 up here. And number 2, we distributed the 7x to both terms. That's what we did second, distributed the negative 7 to both terms. And we got the answer, negative 14x plus 35. There it is in red, negative 14x plus 35. The only additional step is, what could you combine? And that would be the two middle terms you could combine. So this section, it's as easy as distributing. Some math teachers in the past have referred to that as FOIL method, right? But FOIL method is really completely unnecessary. What is it really? It's just distributive property, right? You know how to distribute, and that's what we're doing. You're just going to distribute one term at a time, okay? So even this one right here, it looks crazy, but it's not. We're going to distribute one term at a time. I want to use this box right here. I want to distribute the 2x first. I want to do this in red. 2x times x. What do I get? You look at the coefficients and multiply coefficients. 2x to the third, right? This one has an invisible coefficient of 1. 2 times 1 is 2. X times x squared is x to the third. Okay, how about 2x times positive 3x? Positive 6x squared. Again, you multiply the coefficient 2 with the coefficient 3. That's 6. And then the x times x is x squared. And then how about 2x times 5? Positive 10x. So we've distributed the 2x. Now let's distribute, since we already distributed the 2x, let's distribute the other term. Let's ignore the 2x. So here we go. Let's distribute now the negative 1. I want to use a different colored pen. Negative 1 times 1x squared. That's simply going to be negative 1 with an x squared. And then negative 1 times 3x. That'll simply be negative 3x. And then negative 1 times positive 5. That is simply negative 5. Now after that, you have to combine like terms. Now, this is one way of doing it, where you start combining your highest exponent term. You want your standard form polynomial. So this guy, you can't combine it with anything else because there's no other x to the thirds. So you're going to put that down as the first part of your answer. 2x to the third. And now let's move on to the next highest exponent, 6x squared. I want to combine that with the negative 1x squared. And what do we get? 5x squared, right? Positive 5x squared. If you have $6 and you take away one of those dollars, you're going to end up with $5. But in this case, x squares. Let's move on to the x's. We have 10x, positive 10x, take away 3x. Positive 7x. And at the very end, we see this little minus 5. That's going to simply be the constant minus 5 at the end of our polynomial. And just for funsies, if I classified this would be a cubic polynomial. The degree is 3, many terms, polynomial, cubic polynomial. Now, I want to do the same exact question a different way. Check it out. Okay, so we know we need to distribute. Let's start distributing the 2x. What's 2x times x squared? 2x cubed, 2x to the third. What's 2x times 3x? Positive 6x squared. What's 2x times 5? Positive 10x. Now let's distribute the minus 1. Minus 1 times x squared? Negative x squared, or negative 1x squared. Now check this out. Instead of writing it right here, negative 1x squared, which we did on the last question, the last time we did this, that's what we did. I'm going to not put it there. Instead of writing it right there, I am going to write it below what I'm going to combine. So negative 1 times x squared, that's a negative x squared. I'm going to put that below this other x squared. Check it out. Negative 1x squared. Okay, now let's distribute some more. Let's go negative 1 times 3x. That'll be a negative 3x. And again, instead of writing it over here, negative 3x, I'm not going to write it on the side. I'm actually going to put it right below the other term that I'm going to match it up with. So negative 1 times 3x is going to be right below the 10x. It's going to be negative 3x. And last but not least, negative 1 times 5, that's negative 5. And there is no other number without variables, so there's nowhere to line it up. I'm just going to put it over here, minus 5. Now, what this does, it kind of makes it a little more organized, a little bit more easier to combine. So when you do combine them, it's kind of like linear combinations, where you say, okay, the 2x to the third, there's nothing to combine it with. The 6 take away 1 of those is going to simply be positive 5 of those. And the 10 take away 3, it's going to be 7 of those. And the minus 5 comes down, and there's the same exact answer. It's just done a slightly different way. So it's totally up to you guys. You could have written this whole thing over here, but as we saw on the previous one, let me go back to it way on the other copy. It becomes a huge, nasty looking polynomial where you have to combine like terms, and it's probably a little easier to make mistakes. But when you stack them up on top of each other, it's a little more organized, a little easier, right? So I would start stacking them especially when you have a binomial times a trinomial and you get a lot of terms. I might not do that when it's a binomial times a binomial. Like right here, a binomial times a binomial, it only produces 4 terms and 2 of the middle ones get combined. But when you have a binomial times a trinomial, you get a bunch of terms, and it's definitely better to, instead of having this long situation, a bunch of different terms that you're combining, it's more organized to stack them up on top of each other and just pretend that you're doing like combining like terms. This guy comes down, there's nothing to combine it with. This one and this one gives you 5, gives you 7, and there's your answer at the very end. Okie doke?
Yes, sir.
All right, so let's take a look at our homework now. By the way, will be done on a separate video.